geeks and hackers in the world. And we're here at the church, the most northern church in the world. And I just went to the ATM, which had a picture saying the most northern ATM in the world. So. There's room here for us if you want to like bring a chair and sit. So you don't have to sit out there on the fringes. Yeah.
In the cold.
You can go out. You can go around this way. It's probably easier. Just don't trip on the wires on the way.
Well, actually, we'll go to the most northern hospital.
Yeah. Cool. Okay. So we're at the church, and they've been very kind to lend us this for the small amount. There's a little bit of paying for the coffee and 300 Norwegian kroners. So this is really good. So of course, show the respects. Don't have to say that. Cool. So you all know me. I don't think I need to introduce myself. So
is there a live stream somewhere?
there is a live stream, yeah.
Live stream.
Follow. Yeah, look at Twitter. Look at Twitter for the hashtag ArcticJS, and you'll see you'll see links to the live stream there.
And the hashtag.
Speaking of the live stream, it would probably be good if people kind of didn't maybe didn't connect to the network or something.
You can do something. So there's no BitTorrent.
Okay, cool. The master, the live stream master says that we can connect to the network.
Or we can compromise, just throttle your torrent clients.
Yeah.
Half speed.
Cool.
Yeah, it's live.
So I'm going to talk about security vulnerabilities in printers, and the reason why I'm going to talk about that is because I recently was looking at the AirPlay protocol, and through that work I discovered the Bonjour ServCon protocol, which I knew about, but I didn't really know how it worked. And the way that works is relying heavily on something called multicast DNS and something called DNS service discovery, or DNSSD. So I was looking through this huge list of services that you can broadcast on the internet, on your local network, because it's multicast. And there's a huge list of like authorized services, and I was looking through the list, and one of them is called IPP, which is short for Internet Printing Protocol. And I was like, what the printing without drivers? That sounds awesome. And I looked into it, and apparently it's using HTTP as a transport protocol. And then you can see the content type is IPP, application IPP. And then the body will be a binary blob of data, which is the actual operation protocol. And I found that the way it works is that it talks together using what's called operations. So each request that the client makes to the printer is an operation. And here a list of all the possible operations that a client can send to the printer. And a lot of them have nothing to do with actual printing, but there's one called print job. There's also one called create job, which will queue a job for printing. But print job, well, it's the normal one you probably use. But there's stuff like cancel job and pause printer, get a list of jobs, get a list of printer attributes, which is basically like how much toner do you have, like how many trays, or are the paper trays filled and stuff like that. So the client can communicate with the printer using these operations, which is basically just HTTP requests. And each operation have an ID that is located in the third and the fourth byte of the binary body of the HTTP request. And the HTTP request is look like this. I have it in hex on the left, and you can see there is a version, and there is the operation ID, which I talked about before, You have a request ID, and the request ID is you just, as a printer, you're just supposed to echo that back to the client, so the client can have multiple requests going on at the same time. And then there is a list of headers, which are called attribute groups. And this is one attribute group called operation attributes, but there can be multiple of these groups in the headers. And each attribute group have a set of attributes, and an attribute is basically just a key value thing with a name and a value. And at some point, you get down to the end of attributes, and then you know there's no more headers. Now everything else is going to be the actual document that is printed, if it was the print document operation. If we're just getting the list of attributes for the printer, for example, like a toner and stuff, there would be nobody. So I implemented this, a very, very low-level protocol for this called, or an encoder-decoder called IGP Encoder, which basically takes the same format and just makes it into a JavaScript object. And you require IGP Encoder. You have your buffer with all the data from the request, and you decode it. You get a decoded object. You do whatever you want to do with that. Then at some point you want to respond to the client. You build a response. The decoded version looks very similar to the response you see here, but you build a response setting a status code, kind of like HTTP. Then you echo back the request ID. That comment there should have been on the line before, but anyways. Then you respond with a similar set of headers. So the stuff that the server sends back is very similar to the stuff that the server receives. So there's also these headers that are called attribute groups, and you have them here, et cetera, et cetera, et cetera. There are different types, and I'm gonna skip that. And then obviously, if you were the client, if you just imagine this is a client talking to a server, you could then add some data, and then you encode it, and then you get a buffer, and then you can send that buffer. So what I did was I implemented the bare minimum. So the spec required that you implement print job, validate job, get printer attributes, get jobs, cancel job, and get job attributes. And I implemented that into IGP printer, which I'm going to show you now. Let's see. Boom. I'm going to just switch on mirroring here, because otherwise this is going to be hell. Okay. So let's make a printer. So we require IPP printer, and we make a new printer, call it ArcticJS, which is a good name for a printer. And then we listen for the job event on the printer, and then we do stuff with it. For example, we could write to a file, create write stream, and we're gonna get it in the PS format, which is a PostScript format. So good, like this. And then we run the printer. And what's going to happen now is it's going to advertise itself on the network using the puncture protocol, or the zeroconf protocol. So all we need to do now is go into the printers. I don't know if you guys can see this, but you have your operating system printers and scanners page here, and you can add a new printer, and it will find ArcticJS on the network, and it will say, hey, this is a PostScript printer, and we just click add, and it will install it, and there's no drivers, everything just works. And now I have a printer. So now we can go to, for example, the schedule here for the conference, and we can print that, and we select the ArcticJS printer, and we click print, and we go back here, and while it's printing, we just wait and hope, and now it's printed. We're going to exit the printer, close down the printer, and we can open foo.ps, and it'll open in preview, and there we have the printed document.
Totally random, unrelated question, but what's your IP address?
That is a good question. I'm not at liberty to disclose that. Let's see. Displays, turn off mirroring again. Cool. So, now we come to the fun part. How do we hack this? So, while I was reading the RFCs for this standard, I realized, so the way this works is it's using zeroconf, the zeroconf standard, to advertise itself on the network. And it advertises, this is my host name, I'm listening on this port, my properties. And everybody on the network can then listen on this. That's how you saw that my operating system discovered, hey, there's a printer on the network, because it's listening for this and displaying the list of printers available. So what if two people, so that's the attack vector, that's zeroconf, the zeroconf protocol. So what if two people on the network both start a printer called ArcticJS with two different host names? Since the name is the key here, the whole point of zeroconf is that, hey, we don't want our users to enter IP addresses to connect to a printer. We just want them to remember a name. So since the name is the key, so you can't have two names that are the same. So the protocol have defined a way for these things to resolve themselves without human intervention. And the way they resolve themselves is that the printer that already had the name, or the service, doesn't matter if it's a printer or anything else that is using the protocol, the entity on the network that already had the name that somebody else is trying to claim will have to change his name. That's the rule. So if you have something on the network and you see somebody else saying, oh, I'm called this name that you're called, and you're like, wait a second, that's my name. What you have to do is first check that this is not like just a fluke package that you should ignore. So first you probe, you ask the network, is there anybody else called my name? And if somebody responds, yeah, I'm called this name, then your only choice is to change your name to something else. And usually the services does this by adding -0, -1, -2 after their name. You've probably seen that sometimes when, like, I've seen it with my computer is called Watson on the network, and they get into a conflict, and then one of my devices renames itself to Watson 2. So that is that exact thing happening right there. So what you could do is the attacker could send a malicious MDNS announcement saying, hey, I'm called ArcticJS, I'm a printer. The target is then forced to change its name. And all clients on the network, all users on the network will then see that, oh, now this printer that is called ArcticJS changed not its name, but it will see, it won't know that there's another printer now called ArcticJS -2. It will just see, oh, the host and the port of the printer I have in my list of possible printers changed to a new host, which is announced in the malicious DNS, MDNS announcement. So now all clients on network will point to your malicious printer, port of the attacked printer. That way, people will not see that, hey, why are my printers not coming out? Because the print jobs are coming out. You're just in the middle. You just injected yourself in the middle of that conversation all of a sudden. So let's see this in action. Like this. Okay. So since we don't have a printer in this network, I will of course use my printer module from before to make a printer. So let's see. So I'm just gonna I'm gonna go in and start the printer from before. So now the printer is running. Actually, what I will do is I will set the debug flag to IGP printer. That way we can see what's going on. So we can see that it's receiving jobs, etc. And then we'll go up here and let's just expand this window for a second. And so, oh, that's not the right, what is it called? It is called that, yeah. So I made this called BCC, blind carbon copy. It's not on the interwebs yet. So all this does is basically ask the user to select a printer that he wants to hijack. It then advertises itself as that printer that the user selected. And I'm using something called IPP spy. That is on NPM and GitHub to intercept the calls. But I'm going to advertise myself, since my printer is not capable of changing its name yet. I'm going to advertise myself as my proxy instead, but the concept is the same. So if we run this program, it will look at the network and see what printers are available, and it will ask me to choose one of them. There's only one printer here. It's called ArcticJS because we started it down here. And I will type 0 to select that printer. It's now taking over ArcticJS. And all I have to do now, so in the real world, what would happen was that this printer down here would say, oh, somebody else is called ArcticJS. And it will be forced to change its name to something else. Because we don't have a real printer here, what I'm doing is I'm not advertising myself as the same name, but oops, yeah. But I'm advertising myself as a proxy. But the concept is the same if you believe my name change works. So for the purpose of the demo, we have to install, somebody else is playing. We have to install my proxy.
Always fun.
And now I installed my proxy, and we can go again, and we can print to my proxy instead of ArcticJS. But normally it would just have been ArcticJS, of course. And so you saw a lot of scrolling down here. That's because the actual printer did receive the job, but also our fake printer received the job. And while forwarding it to the actual printer, it just wrote it to foo the PS up here. So now we can cancel the proxy, and we can open foo the PS, or we can do like this, and we can open it like this. And we have well, I should have called it something else, but we have it here. So it works.
Woo.
And where's the displays thing again? There, boom, mirror. Okay. So let's go back to, there we go. That's actually my last slide. Thank you. How, what do you think about this?
Have you tested it on a real printer?
I have tested on a real printer. I went to my office the other day at Upbeat and hijacked their printer. They don't know yet that, but the only downside of this is that because you force the printer to change its name, according to the standard, the printer actually now have to assume this name is the default name. So it will never change back unless a human goes and changes the printer name. So when you leave the network with your fake printer, nobody will be able to print anymore because now the printer is called something else. So you will see like a trail of printers being renamed whenever I'm on a network, or not.
If you spoof the name of the printer again, will it rename itself back to the old name?
Yeah, so if you take the new name and spoof that like once more, it will keep adding numbers to it. Yeah, so it will just keep incrementing this -1, -2, -3.
UN 32 plus 1 time.
Yeah, that could be an interesting attack vector.
Could you join a network, or like could you send this to a network using some sort of thing so you don't have to join the network while being there? Like could I hack a printer in America right now?
I mean, you need to be able to send a UDP packet to the printer. You don't have to send it as multicast. You can send it as unicast. But if you have that capability in some way, you can force a printer to change its name. If the printer is using the IGP protocol, of course.
Yeah.
Because there are many other printing protocols, have to say that. And you can switch off IPP if you want to, and not all printers support IPP, but a lot of printers support IPP.
Yeah.
Are you planning to put the code up on GitHub?
Yes, I'm planning to put the code on GitHub. I haven't thought about the implications of that yet, but since I basically showed all my code here in this slide, and this is what I have here is basically glue code gluing together a bunch of modules that I made. So there isn't that much left to do yourself. So I probably should put it up. Plus, I don't think there's really, like, I think, so what let me rephrase this. What can a company do to protect its printers? You guys have any ideas? Besides, say, switching off IPP.
Disable multicast.
Or disabling multicast. Is there any way to still use that technology but have it safe? Matthias, you were saying something earlier.
No, I'm saying there isn't multicast unit, there's DNSSEC.
DNSSEC, yeah.
Supposedly could help.
That's a really interesting idea. I haven't tried DNSSEC and I don't know exactly how it works, but people more familiar with that might be able to verify it. Or, but I'm pretty sure it's not switched on by default, and it's not something that your average small office will know how to set up.
I have a question.
Yeah.
Have you tried doing this for other emptiness things on printers, but like iPhones are also the storable pool?
I haven't tried to do it for anything else than printers. The question was if I tried to do it for other things than printers, because IPP is, Bonjour, or the Bonjour protocol, the ZeroConf protocol, works for anything types you can advertise. Apple TV uses the same mechanism to broadcast its location on the local network. You can have HTTP servers. Your actual, like each of your Macs right now broadcast your hostname.local So anyone here can say ping Brunhilde.local, and you will ping the laptop that Macintosh has. And the reason why that works without a DNS server is because it's using multicast DNS to advertise its hostname. And if one of you guys went in and said, "Oh, now I'm called Brunhilde," Macintosh machine will have to change its hostname. So you can do this with anything, actually. Any other thoughts or questions?
Does the name like have a length limit?
Yes.
Because if you like keep spoofing it, it will hit the limit?
No. It's limited. Is longer than that. There is a length limit. I can't remember off the top of my head what that limit is. I think you usually say. I think you usually say that you should keep your names below 100 characters. So that shouldn't be a problem with the upper limit of an integer. Unless your name before is very long.
Okay, so it just keeps renaming to like 2 instead of 1. So
Yeah.
It's not keeping.
It's not adding hyphens. It's just change. Like the protocol doesn't say what to do, but I've just noticed that any implementation I've seen so far does that by adding a hyphen and then an incrementing number after the name. But the protocol allows you to do whatever you want to change your name. You just have to change your name. Or actually, so the protocol also says that if you keep changing your name, and after a certain amount of time that you can't find an available name, you have to take yourself offline and report an error to the user. But if you are some device without a screen on the network, the user is usually a log file that you write to. So, yeah. Cool. Thank you.
Have you tried writing something that just DOSs something by forcing it to keep renaming?
I haven't tried to force it to just keep renaming. I haven't tried to see what happens. I once had my machine I don't know what happened. I think my phone and my laptop was in some kind of 200 and something. I've seen so far.
So it didn't give up before then, or?
I don't know exactly what happened. That was before I knew what was actually going on behind the scenes. Cool. Who is the next speaker?
So, on the schedule, we have Richard. Please.
Me, yeah.
Awful. Oh, the schedule changed, yeah.
Everything is scheduled.
Oh, that's right. No, it's here.
Since you just tweeted the live stream for Nuffle, do you want to go now?
Yeah,
The links won't change, so.
I get.
Let's try it. Where is the new schedule? Is it not on the issue?
The schedule is